Until recently, the only ports which have higher than 10 gigabits speed are the ones from two of my UniFi switches. They are SFP28 ports and they support 25 gigabits speed, but I only have totally 6 of them. It left me very few ports to be used for other devices. I badly need a switch to have more SFP28 ports. I initially considered buying another UniFi Pro aggregation. First, it's very expensive. Secondly, it only comes with 4 SFP28 ports. And again, I need to use some of them as uplink. It doesn't really help too much. Unfortunately, ubiquitous leaf switch was never released, so I ran out of option in UniFi world. Then I started researching on internet and eBay. I decided to purchase a very cheap 100 gigabits used switch. The switch in the middle is the one I purchased from eBay, Celestica DX010. It has 32 QSFP28 ports, which support 100 gigabits speed, but you can use the so-called breakout cable, so each port can break into 4 SFP28 ports. In total, 32 multiplied by 4 SFP28 ports, which is much cheaper than buying, let's say, UniFi switches. To work with the 100 gigabits switch, I also need a 100 gigabits network interface card. So I searched eBay and I found this Mellanox ConnextX-4. It's very affordable. I went with the one-port version. Now I have the NIC, I have the switch. I'm still missing a cable. Let's first compare the 100 gigabits DAC cable with the normal 10 gigabits one. As you can see, they have different sizes and the cable itself is much thicker and much strong. After I received the switch, the NIC, the cable, of course, the first thing I wanted to test was to establish a link among all of them, right? To verify, okay, everything works together. But it turns out it's much more difficult than what I thought. Let me share my experience with you. Of course, in real world, the diagram is not this easy because we need software to run the testing to make the hardware work. So this is the real world configuration. Let's first check the switch. The switch supports the open source Sonic network operating system. In fact, that's one selling point to me. That's a major reason why I went with this switch, because I want to learn Sonic. Here, of course, to make whatever real world testing, we need a uplink. That's why I use another breakout DAC cable and connect this switch with my existing home network, which is the UniFi switch. So this part works fine. There's no any problem. So in this video, I'm going to skip the details for this part. Now let's see the NIC part. I plugged the network interface card to a Supermicro server, which is running EXXi7. And I wanted to use a Linux virtual machine to do the testing. Basically, just to see whether I can ping any IP address from this Linux virtual machine. That's the simplest thing I could do. As I mentioned, this part, it worked from the beginning, no problem. But the first problem I got was in the NIC part. My EXXi simply didn't recognize this card. Second problem, after connecting the DAC cable, it simply didn't have carrier. So there's no link, no LED light. Third problem is in the switch part. The virtual machine couldn't acquire IP address. Okay, let's go through the 3 different problems. Let's see what's the troubles I encountered. After installed the network interface card, I powered on the EXXi server. If I go to hardware, under PCI devices, I do see this NIC, Mellanox ConnextX-4. That's perfectly correct. But if I go to networking, under physical NICs, I still see my existing 6 10 gigabits ports. I don't see anything about this 100 gigabits. Apparently something's wrong, right? So normally this situation is because it's missing drivers. No problem. If it's missing driver, let me install driver. I followed the instructions from Mellanox website and I installed the drivers for EXSI, and so I can confirm that from manage packages, and here you see the NMLX file is for this NIC driver. Okay, so the driver is loaded, everything should be working, but if I go to networking under NICs, I still don't see it. So there's something fundamentally wrong. I did more research. I checked the Mellanox website for this particular NIC and found this. It supports InfiniBand and Ethernet. Then I realized, okay, maybe that's the reason, because this card supports 2 modes and maybe my card is not in the Ethernet mode. That's why EXXI doesn't recognize it as a Ethernet NIC. I found another document from Mellanox. This is the document I found. It's a how-to document. It's about under EXXI, how do you change the port type? That's exactly what I need to do, right? But that's where the problem starts, because I follow the exact instructions to install the software. It basically is a tool set from Mellanox. The installation went well, but I still don't find those needed commands in EXSI. It simply doesn't exist in the mentioned folder by this document. I tried both EXXI 6.x and 7.0. 2 different physical servers, 2 different EXSI versions, the exact same problem. Okay, I know that's what I need to do to change the port type, but I cannot accomplish it under EXSI. I have to go another way, which is I unplug this card from my Supermicro server and then installed it on a Windows PC. Then let me try to run the Mellanox tool under Windows. Let's see whether I can change the port type. Now I already installed it in Windows. I also installed both the drivers and the tools from Mellanox. Now let me run the tools to see whether I can change the port type. First, let me decide the device name. That's a very special thing for this Mellanox card. You need to know the internal technical name, then you can change the type. I will run MST status. It gives me this internal device name. Okay, this is the command I'm going to run. First parameter is the device name. I got it from this previous command. I will set the link type of the port 1. Remember, my card only has 1 port, to value 1 for the InfiniBand, and the value 2 is for Ethernet. Oh, sorry, I need to set it to value 2. Let me hit enter. Okay, here as you can see, the next boot means the current setting, which is 1, which is InfiniBand. But because I set it to 2, the new value will be 2, which is Ethernet. That's exactly what I want to do, so I will say yes. Okay, done. Then let me remove it from PC, re-plug to my Supermicro server. Let's see whether now EXXI can recognize the card as a Ethernet NIC. I have reinstalled the NIC to the Supermicro server and put it up. As you can see in hardware, yes, I can still see this card, no change, which is good. Then let me go to networking. Okay, here under physical NICs, you can see there is a new NIC, and this is the EXXI driver I installed previously, and now it's showing link down. Perfect, that's what I expect. Let me see whether here it shows anything about 100 gigabits or not. Yes, See here, it shows 100 gigabits. Great. The NIC is installed under EXSI. It already shows up. Now let me move on to next part. Let me physically connect the NIC with the switch using the DAC cable. I powered on the server, plug in the DAC cable. As you can see, there's no LED light. Don't be confused about the green light. That's something on the motherboard. Has nothing to do with the NIC. Because I haven't plugged in the other end yet, that's expected result, right? Let me try to plug in the other end to this switch. Before plugging in the other end of the cable, let's check what the switch looks like. As I mentioned previously, I need an uplink for this switch so that my computers can get IP address. In the port 1, I already plugged in a special cable. It's a 40 gigabits breakout cable. It works fine. As you can see, the LED light is already on. Now let me plug in the 100 gigabits DAC cable in the port 5. Let's see whether it's also plug and play, if you will. Plug it in. A little bit difficult. Try again. Okay, plug in. Tight and fit. But as you can see, the LED light remains off. It's time to SSH into the switch. Let me see what's the status reported by the switch. Okay. As you can see, it's running Sonic, the open source network operating system. Let me run the command show interfaces status. As I mentioned, the first part, I already plugged in a breakout cable. So you can see the 10 gigabits, its operational status is up, which is good. But the fifth part, which is the one I plug in the 100 gigabits cable, it's showing down. Even though here it's showing the correct cable type, it's QSFP28, which is 100 gigabits cable. It recognized the cable, but the operational status is showing down. There must be something wrong in the cable configuration. Let me do some internet research to see what's happening. There are several similar issues reported on the GitHub of the Sonic operating system website. For example, this one, and someone replied, check the FEC setting. A Google search of FEC and RS returned this result. So first, FEC means forward error correction. RS is a RFEC type, stands for Reed Solomon. It applies to some specific 100 gigabits cables. Let me try the RS setting for FEC. I'm back to the SSH session to the switch. Let me run this command: config interface FEC Ethernet 16 RS. So Ethernet 16 is the interface name for the Ethernet 5th port, which is the one I want to use as the connection for the 100 gigabits cable. And then I want to set the FEC setting to RS. Okay, done. No error. Now let me run the show interfaces status again. Okay, see the Ethernet 16, the 5th Ethernet cable. And now FEC is showing RS and the operational status is up. Now I see the green LED light for the 5th part, which means the no carrier issue has been resolved. I'm so happy now. Let me double check in EXXI. As you can see here, this physical NIC interface is showing 100 gigabits and is showing green color. That means the link is established. Hardware perspective, no problem already. Now let me boot up this virtual machine. Let me see whether I can achieve my very first goal to have a successful ping. Now I'm in the Linux virtual machine. It's just booted. I'm not sure whether you can see this small icon, but it shows the connection is not successful. Let me click on it and to see what's the detailed error message. Ignore this speed, I believe, because that's something EXXI simply reported the card as 10 gigabits, but it doesn't matter if it's 100 gigabits. In my understanding, the virtual machine can achieve the real speed. But what I'm really interested is the IP address part. Okay, in the details, it doesn't show IP address, and in IPv4 the default setting is DHCP, and it doesn't have anything acquired, which means the uplink doesn't really work. So this virtual machine cannot really talk to my existing home network, cannot talk to my router, the DHCP server, to get IP address. There must be some more changes needed in the switch. And back to the switch SSH session. This is the existing status results. I noticed one thing. Under VLAN column, all the interfaces say routed. It doesn't look correct to me because I know this operating system is very complicated and it supports many functionalities, but for now I simply want to do a successful ping, and I simply wanted to work on a layer 2 switch mode. When it comes to VLAN, I wanted to be trunk instead of routed. Apparently the default configuration configured it as layer 3 mode. Let me go to the configuration file to see whether that's the case. Go to the etc sonic, then the configuration file name is config.db.json. I see many IP addresses already. Apparently by default each interface is configured with a IP address. Yeah, it configured device neighbor. So let me run several commands to remove those default settings, revert it back to a very simple layer 2 switch mode. Now I want to see the current IP address configuration for each interface. So I'm running this command, show running configuration interfaces. And I'm interested in two interfaces. One is the Ethernet 0, which is the uplink, and the other one is Ethernet 16, which is the one I used for the 100 gigabits cable. So I get the IP address here. Let me run another command to remove the IP address configuration. Let me try this command first. Config interface IP, remove Ethernet 0 with this IP address, which I get from this result. Okay, it's working. Then remove the other part, which is Ethernet 16. IP address is 8. Right? Okay, no error. Now let me run the show running configuration interfaces command again. I don't see Ethernet 0 and Ethernet 16, which is good. Let me run this command to disable BGP neighbors functionality. I don't really need it now. Okay, it's done. The next step, let me add a VLAN. In fact, any VLAN should work for my simple testing. Let me add a random one, a VLAN 99. Okay, it's done. Then let me run this type of command to add two interfaces to the untagged VLAN ports. First one, add the uplink Ethernet 0, add 99 VLAN, and then the -u means untagged. Basically, I want a trunk VLAN. Okay, done. Set the Ethernet 16, which is for my 100 gigabits port. Show interfaces status command again. See, for Ethernet 0, it says trunk for VLAN, and for Ethernet 16, it says trunk for VLAN. Let me go to the virtual machine to see whether it can acquire a IP address. Good. See the network icon in the right top corner? It's showing the solid Ethernet status. That's a good sign. Let me go to the setting. Okay, I got IP address here. Everything's working now. Let me do a final test to finish this exercise. Let me ping my router. No problem. It pinged successfully. Finally, after 2 days struggling with the network interface card settings, the DAC cable settings, and the switch configurations, finally I finished this seemingly very simple request, which is do a first successful ping. So I never expected this type of experience before I started trying 100 gigabit switch, because in the 1 gigabit switch world, you simply have a Ethernet cable, you have a working switch, then you have a computer, you simply connect them, everything should work out of the box. But apparently it's not the case for the 100 gigabits world. Okay, now I'm very happy. Thank you for watching.